Welcome to Properties of Exponents. This is the first lesson in a series of lessons to help you understand some of the properties of exponents. Today we will look at product of powers. Earlier in this unit, you focused on functions, modeling exponential growth and decay, and you dealt with exponents. It's important to understand these properties so that you can work with different equations that are exponential in nature. So let's first define a product of powers. And we'll do that by looking at this first example. What does 2 to the third power equal? Well, if we define this, we would define this as 2 times 2 times 2. There are 3 2's. That's what 2 to the third power means. So let's apply that. What if we have a variable to the third power? Well, then what does that mean? That is also defined as x times x times x. We have 3 x's. So our exponent tells us how many of the bases that we have that we're going to be multiplying together. Let's extend it even a little more. What does 2 to the third times 2 squared equal? A lot of people will want to say, oh, well, I see the times and I see these exponents, so I'm going to say 2 to the 6th power. Is this correct? Take a minute, think about that. You should say no. That is not correct. And that's because we need to apply the definition. What does 2 to the third mean? 2 to the third, remember, means 2 times 2 times 2. And then times 2 to the second. Well, by the definition, 2 to the second is 2 2's. So now we have 2 times 2. How many 2's do we have in total? 1, 2, 3, 4, 5. So what we really have here is 2 to the 5th power. We have 5 2's. Therefore, be careful. This is a mistake that is often made. When we see a times in here, we automatically think multiply the exponents. But in fact, what are we actually doing? How did we get 2 to the 5th? Right now, you should be thinking, well, we added them, 3 plus 2. Let's apply that down here with some variables. What does a to the third times a squared mean? Well, remember here we have 3 a's and we have 2 a's here for a total of 1, 2, 3, 4, 5, just like we did in the problem above. So a shortcut, instead of writing out all the variables or all the numbers, we can just add the exponents. 3 plus 2 is 5. How about down here, this last one? What's 4 to the third times 2 to the third? Well, these have different bases. So can we just add the exponents? Well, that wouldn't work out because we have 4 times 4 times 4, and then 2 times 2 times 2. We can't just add all these together, so we can't combine this. The only way to solve a problem like this would be to actually do the multiplication. Let's go ahead and summarize what we found. The product of powers rule says that if we have common bases, then we just add the exponents. We can write the formula or the rule out like this. If we have a base to the n power times a same base to the m power, we know that the answer will be whatever that base is to the n plus m power. Let's wrap up by trying a couple of quick examples. Let's find the values for the variables to make the statements true. Pause the video and see if you can answer these on your own. Let's look at the first one. 2 to the 10 times 2 to the third equals 2 to the y. What will y equal? Well, we just said common bases, add the exponents. So y will equal 13. If we put a 13 in here, this will be a true statement. What about number 2? 9 to the w times 9 to the x equals 9 to the 5. Well, we do have common bases, so we can combine these. Well, what are we going to add together to get 5? Well, there's multiple choices here. If w is 2, then x would have to be 3. What if w was 1? Then we know that x has to be 4. No matter what, we have to total these in order to get 5, which is on the other side of our equal sign. We could also say if w was 0, then x could be 5. And we'll talk about the 0 exponent in a later lesson. So there's multiple answers for this one. What about this last one? Well, 3 doesn't have an exponent, or does it? If we don't see an exponent here, it's understood to be 1. 3 to the 1 power is simply 3. That means we have 1 3. Well, now we can add these together. 1 and 7. In this case, y has to be 8. And that concludes our lesson today on product of powers.